Okay. Tonight is the tonight is time now is 11 p.m. The date is the 10th of May 2026. What am I trying to do? I'm trying to formalize this properly. What do I mean? Okay, so using the Laplace transform, Alpha Lima, Alpha people, P for Papa, Alpha Lima, A for Alpha, C for Charlie, E for Echo, Laplace transform. I'm trying to form this properly. So, I'm trying to prove or disprove. I'm trying to prove that time is non-linear. Time is non-linear. Time is non-linear. What do I mean by this? I'm trying to prove that time is non-linear. Time is the fourth dimension. No, it's not a dimension. It's a non-linear because if time is non-linear, we are on a linear sequence of time. And that would mean there are parallel universes. So if time is non-linear, what this means there are parallel universes that exist. And if time is linear, that means we are one universe. We only there's one universe, because time is linear. So how does this work in practice? So I'm gonna define it properly. So I'm gonna read the words of this. So let me read what I wrote on paper. Proof that time is non-linear. Channel 0 transmitter, channel 1 transceiver, channel 2 verifier, or broadcaster. Uh, 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 uh. Let's create channel 3. Channel 0, channel 3 is a broadcaster. So Alice is sending a message to Bob on the internet. Alice is sending a message to Bob on the internet. This is the protocol. Uh, 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 Transmitter, receiver, verifier, and channel 3 broadcaster. So channel 0 is with transmitter, channel 1 is receiver, channel 2 is verifier, channel 4 is broadcaster. And we're trying to get channel 3 we're trying to listen to a broadcaster of a message in a sequence of systems. So Alice is speaking to Bob. So Alice transmits a message. Alice transmits a message from channel 0. Channel 0, you get channel 1, receiver. And that's Bob receiving the message on that channel. Now, channel 2, if you want to check the message received, verifier, is from Alice. He looks at the verifier. Yes, this message comes from Alice. Yes. And it's an Alice payload. Now, the Miracle B sequence is noise, no signal, and there's a payload attached to that signal. So noise is nothing's being heard, But how would this work mathematically? So this is very vague right now, but the goal is to have noise, no signal, and signal be four characters of position. So noise means there's no information. No noise means there's nothing, just a medium, but still no connection. No signal means there's connection, but it's also nothing. A signal means we have something. So noise connects to no noise, signal connects to no signal, and you have some kind of a radar sweep. I don't call it radar sweep, but it is what it is. It is if you look at it behaves like a radar sweep. So the principles I'm saying is that the Alex talking to Bob, and if there's a signal, if Alex sends a message to if Alex say Alex and Bob are now in two different universes. In two different universes. This will then if they send a message across dimensions, across universes, time is non-linear. Time is non-linear. Time is it's non-linear because time will have to skip a dimension of and that's what proof. So it's very it's like I'm interested in proving this thing because it interested me. It's called nuclear OS, but it's kind of a sci-fi. So if I can write a program that proves this, I'd be very happy. But so if a broadcast is if say if Bob broadcasts a message, no, if Alex broadcasts a message, we have two. So you can have a system like this. You're gonna have a system like this. So you're gonna have a system like this. Noise, no noise. On the noise, no noise on the S. Noise. I mean, no noise on the no noise on the x-axis, positive x. Noise on the y-axis. No signal and signal on the y-axis. But this is the sequence here I'm showing here. So you have this kind of a planar two-way dimension, a two-way axis. And it's very interesting to understand that if Alice and Bob are in two different dimensions of reality, two different backgrounds, I don't even know how to calibrate, but they have to map. There's kind of a relationship map between the system, like a reduced homogeneous system. But if this works, if the two from the someone in another dimension, and how time will be non-linear, so how would this work? It's conceptual, but it's very conceptual. It's very interesting to have me think about this, right? Tonight. But basically, I'm trying to take a function of time, a function of space, and convert it to a function of time, Laplace stuff. So let me try to do some kind of intuition here. F of s, a function of s equals of time equals a function of space. Space to volume or area. A function that takes space, a volume. So let me take a simple f of space equals f prime of x. No, equals to g prime of x squared plus 3. So if a function of space integration, this is valid math, but I can't put my name to it. So basically, a function of space s equal to g prime of x, but squared plus 3. But this is constant 3. So what the function of time looks like. So let's say some this have a time equivalent to it. So if you did calculate form of this, the time will have the system of g prime. G prime is g prime represents integration of first integration. No, that's the first derivative. So g prime would be basically, it's kind of like, if I don't know why I'm working on this tonight, but it's very complex. People take years to work on this. So let me just say that that's that kind of idea. Connecting between dimensions, how to connect between dimensions. It can be a local dimension, like our universe, but if we can live, if I use my mother, she never lose connection. She never lose connection. An eliminate connection. Eliminate connection entirely. How would I eliminate connection? Like eliminate not having enough connection. Then I'll keep my system connected to the internet or connected to some kind of server, centralized server, or this center distributed server, and that's the idea there. So let's go to the payload. So a noise payload can be 010 A, B, C, D, A, 1, 2. And a no noise payload can be F, 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 F. And no signal payload can be 01A, 01A. And signal can be B. Zero can be 0, 0, 0, 0, 0. Oh, no, wait. No, this is 0, 0, 0, 0. Basically, The goal is to have the sequence represent some of binary stream of information that determine connection strength, the language can understand. Basically, the computer can understand this kind of computer language, and and that's the idea. If I can connect to dimensions, this should be mapped onto the signal noise, no signal, and no noise system. But eliminate no video connection. Only keep solutions, so keep them as a variant or the policy, either have the signal be on top or be everything on hold is a signal, and never lose a signal by running a thread, they always do this. So basically, you can use it as a conceptual system of a holding. So you got signal will be -1, signal will be -1, no signal will be no signal will be 1, no signal will be -1. You want to hold the signal, and that means noise will be -1y. I mean 1y -1y. So y equals 1 -1. Okay, I think I'm making no mistakes here, but this idea, now I can't work on this tonight. I can't. I've got books and I'm reading them. So that wasn't making any sense. Okay. Second thing I wanted to say, my constitution, Oha, Iwu, and the G, looks to me like Dungeons and Dragons. Doesn't matter who's bad inside. It feels like Dungeons and Dragons, and that's what I'm trying to model as kind of a threat model of Dungeons and Dragons. Threat modeling. But apart from that, I'm done. Thank you for watching this video, guys. Dungeons and Dragons is very important to remember that concept. Dungeons and Dragons, Oha, Iwu, Ichi. Dungeons and Dragons. Remember that. Thank you for watching this video.